Hello everyone. So as promised, this is the video on applications of image annotation where it can be applied. So this image makes it clear that this has been a labeled image where you can see car, person, bicycle, building, etc. So let's see what are the applications of image annotation in machine learning and artificial intelligence. So the first one, as you can see, is the two-dimensional and the three-dimensional boxes. So what I do is when I'm been given an image, I will label this. I will tag the particular entity or object in this image, and I can just label it as a pedestrian or a person. I can label this as a sign. I can again label this as a car. I can label this as a building, this as a street light. Okay, this as a board. So there are so many things which can be labeled in this image. So this is a two-dimensional boxes. And when I talk about three-dimensional boxes, the only difference is that it captures the depth also. So if you want to be more specific about the vehicles on road, like whether it is a car or a container or a truck, bus, so three-dimensional boxes would be more useful for this. So image annotation for two-dimensional and three-dimensional boxes. So we what happens is we draw a box around this image and label it accordingly. Okay. So the next is lines and splines. So you see this straight line and you see the curved line. So you can label this also that this is the curved line, this is the straight line. And what happens is this is useful for lane and boundary recognition. And we train so many thousands and thousands of images for the model, and accordingly it is being tested on the unknown data how it is performing, and later on further improvements are being done. So it is also used for these lines are also used for trajectory planning for drones. So wide application for curved, and for in robotics also you can use this. The third is image classification. So I can classify. What I do is I draw a box around this and I classify it as, label it as rabbit, this is a cat, and this is a dog. So over the period of time training thousands and thousands of images, my machine learns that okay, when I get this picture, I will label it as a rabbit. When I see this as a picture or any similar picture, I label it as a cat. Any similar picture of such a species, a dog. So it will identify correctly. Okay. Now the fourth is polygons. Now what are these polygons? They are useful when our two-dimensional and three-dimensional boxes cannot be used here. See the irregularity of the shape of these houses. So what I use polygon here. Okay. So polygon annotations will help me to classify these images into different labels, and then I can train my data on this. Next we see is semantic segmentation. Now what is the semantic segmentation? Now given an image, there are so many features which it's capturing. So what I do is I just segment this, okay, this image into various segments. I segment this as a car, sign, person, different other like trees and etc. are not being labeled here, but you can see that each segment is indicated by a unique color code: green for car, you can see this orange for person, and yellow for sign. So this is how we divide this image into different image labels and do the semantic segmentation of it. So I also call this as the computer vision, because we are training the computer to see image from our lens, from our perspective, and for this we have to train it thousands and thousands of images so that it trains and it correctly identifies on the unseen image, okay, by itself. So